Hi, in this video, I'm going to talk about why is data science so interesting and why everyone should learn a bit of data science. No matter which discipline or which area you are working in, you should know a bit of data science. And I'll talk about why is that so. Okay, so those of you who are new to data science or those who are not familiar with what data science is all about, I'll just briefly talk about what data science is. Well, this is a newly coined word. Most of the things in data science have been there for decades, but it's just that the word hasn't been in use very often. The word was actually coined long ago, but it has only become popular last 5 to 7 years. So is a combination of a lot of things which includes computer programming, data analysis, doing prediction using mathematics and statistics, solving problems using different mathematical, logical, analytical, or operational research techniques, finding out insights from informations or data. If you combine all of them, we call that as data science. Of course, data is the most important part that you build products or you find out insights using data. So that's what people call that data science. And there's so many things about data science that you can read up on the web. There are so many good sources. The best one is of course wiki. Just go and read about data science on Wikipedia, and there are so many questions on Quora, and you can simply go through all of these questions about data science that people have asked and experts have answered about what data science is. It's now used in almost all areas that you know of, whether it's finance, banking, retail, e-commerce, manufacturing, media, government, non-government organizations. Everywhere people have been people are using data science techniques, and data scientists are being hired in most organizations. Okay, so why is it important that if you are a lawyer or if you're a doctor or a or you're a pharmacist or you are an economist, you should know a bit of data science. Why is that so important? Okay, I'll talk about that particular thing, that people who are not at all related to data science directly should also know a bit of data science. That will help, and it will in fact be compulsory skill to have in future, although it is not yet, but in future this is one of the mandatory skills. Okay, so let me take you to your school days. In school days, you must be having one of the few interests that I have just listed out. Of course, it's not the full list. There may be other things that you might be interested in, but most of you would be either interested in mathematics or science, or solving puzzles, or solving Sudoku, or playing chess. Trying your luck in stock market, coding. Not many people are interested in these two areas, but there are some people who are into either stock market or writing code in school days. Some people are interested in exploring languages, different languages, whether it's painting, music, or drama, creative activities, right? Now, fast forward, when you become mature enough to go to college, and then of course after college you start working, you seems to forget everything that you were interested in school. Some people, only a very only a small section of the people actually get to work on what they were interested in the childhood, like whether it's scientists or mathematicians, academicians. Such people are the ones who actually use math, science, or use problem solving skills to kind of work. But most people don't work in these areas, right? And not many people actually even hold on to the creative passions or interest, like painting, music, language, and so on. But with time, things have changed. Now, even if you're working as an analyst in a bank, you're supposed to know mathematics to a great extent. If you are applying for a job as a developer in Google, or in an investment bank, you will be asked questions, whether puzzles, so your Sudoku solving skills, your chess playing playing skills are going to be very useful, or your problem solving skills through puzzles are going to be very useful. um, if you're applying for a management consulting role, or you are applying for more of a creative side of role, like a strategy management or marketing analyst and so on, your skills in language painting or your skills in music are going to be very useful, and people will acknowledge that also while hiring you. Now things have changed of late, that these geeky skills have now been given some weightage what used to not given some maybe decades or a couple of decades ago. Now, how is data science related to all these things, and why am I talking about all these things? Well, data science is also some kind of related skill that we used to have this interest in schools, but we never actually pursued later, most of us. Also, of course, some people get a chance to pursue their research career in a particular field of science or technology, but most of us failed to that for whatever reasons, because of our maybe because we are not lucky enough, because we were not so interested in a particular academic area, or many of us had to drop out of school and colleges just to support our families and start working in the real world, and so on. Well, that has now changed. So you need research scientists even in industry, and you don't have to have a PhD for that. You don't have to publish research papers for that. At the same time, you will be using mathematics, science, puzzles, coding, and so on to solve business problems. So it's not just scientific problems for which you need researchers. You will also need researchers for solving business problems. Okay. And second thing is that you don't need to need to have a PhD for that. So if you have a bachelor's or master's degree, that's enough to be a researcher in the industry, especially in the field of business research or data science in particular. Okay, and that's why data science is interesting. Of course, there are other reasons why it's interesting. I'll talk about most of the things, but it's just that we can relate it to our childhood. A lot of things that we had just forgotten. For example, we studied the distance between two data points A and B, right? But we never got to know where it's being used in the world, until we learn machine learning, right? Then we got to know that no, if you want to fit a straight line between these data points, we have to ensure that line fits very close to the data point so that the distance is minimum, right? And then there we calculated the distance between 2 points, right? Then we also studied about calculus, right? Differentiation, and so on. So if y is a continuous function, so we learned about continuous function, f is a continuous function, and so we did not quite understand that why continuity is important for differentiation or integration. Well, a function has to be continuous, otherwise you won't be able to differentiate that. Okay, simply reason is because if it's not continuous, you won't be able to find the gradient in that particular segment where it is becoming discontinuous, right? So to find the gradient, you need to know y plus minus delta y, and then minus delta y, right? If there is no presence after a certain point, you won't have that delta part of y in that area, and so you won't be able to calculate the gradient in that area. So when we learned about actual derivative, partial derivative, and so on, we quite didn't understand where on the planet we are going to use them, right? Unless of course you are becoming a scientist, most of the things were not useful. But as a data science, you need to know what is a partial derivative of y and why is that important. Whether it's ordinary least square, whether it's gradient descent, stochastic gradient descent, you will be using derivatives to a large extent. Similarly, many areas of mathematics that we had learned in school are now being used in business research. And by the way, the interesting thing is that you don't need to do a PhD for that, to become a researcher, and still you will be keeping up with your interest in mathematics and logic and analytical way of solving problems that you used to have in schools. All right. So after school, I have categorized in three broad categories, but it need not be your area. You might have been into other areas. So either you went to a science or maths or engineering schools, which is more technical, or you went into more professional, non-technical, so to say, areas like accounting, law, management, or finance. Or maybe you went into social sciences like economics, history, or languages, literature, and so on, right? So what happened was that people who went into science and maths, they of course use a lot of what they had learned in maths and science in school. But most people who go into science and maths and engineering, they do not quite end up becoming a researcher there. They actually become applied people. And in the applied area, you actually don't quite use much of what you had learned in school and colleges from books and all. Okay. Um, some people do use. I'm not saying that it's not people don't use. It's just that it's more applied, and you don't quite use at a fundamental level. Okay, you don't solve a maths problem before planning for some engineering activities. You do, of course, some related activities, but that's more applied. You don't quite do any fundamental research work there. In accounting, law, management, and finance, it's more, again, it's related to, there is bit of maths and numbers are there in accounting, also is there in management or finance. But again, people used to be uh, you know used to be more towards intuition, using the intuition to solve problems in this area rather than using mathematics. In social sciences, people have been long been using their writing skills to express their feelings about a particular area, and the research was predominantly on writing, through analytical rigor rather than validating your ideas with data and experimentation, so to say. Social science have never uh, been the same, but of late it has changed, and it is changing quite drastically, and people are using statistical techniques to sort of understand many of the things, whether it's history or there's economics. Well, economics have been using a lot, but even other social science areas have been using. Now, the point is that, so this is college. We talked about school, and then now it's college. Next we'll go to jobs, right? So once you finish schools and colleges, you went into jobs. So you basically ended up getting two types of jobs. Okay. So one where you build things, you build products, and the second where you take decisions. You are more into analysis or decision making areas where you don't have to build a product. You're not into manufacturing, so to say. Okay. So these are people who are lawyers, who use arguments from different areas and come up with their own argument to a particular litigation. Economists, who again come up with hypotheses, ideas, theories, and so on. Management professionals, who don't build anything, but they actually manage people, who could be managing developers, engineers, and so on, but they do not quite themselves build products and so on. A second area is a build. You are more into um, an area where you build things, you develop things. You are a developer, you are an engineer, you are a scientist, where you either develop a particular drug, you're going to develop a software, you're going to develop an electronics instrument which is going to be used. So these people are more into product industry, manufacturing industry, where these sort of people are more into service industry. Loosely speaking, of course, there is no hard and fast rule, but loosely speaking, there are two categories. Now, in the in past, these areas were segregated drastically, and there was no way to connect to these two areas. Okay, but now there is one thing that is connecting these two areas, which is data. Data. There is an increasing importance of data in both areas. Whether you're going to be a decision maker by being a lawyer, an economist, or a management professional, or you're going to be uh, an engineer or a developer who is going to develop products, both are going to need data. Okay, and that's where data science comes into picture. Okay, and so if you go back, data science is related to what you're doing now, what you had studied in schools and colleges, and what your interests were in schools. And that's why I would argue that data science should be, you should learn data science no matter which field of uh, work you're going to do in future. Of course, in many areas you will be expected to learn as a compulsory subjects, but in many areas nobody will ask you to do, but that's going to be very, very helpful if you do. All right. Now, let's talk about the different professions in these two areas, profession A and profession B, and why data science is important in both areas. Well, in professions A, I will categorize lawyers, financial analysts, journalists, marketing, salespeople, operation people, management consultants, and so on. People who don't, build things. Those are not engineers, so to say. In profession type B, where you will have engineers, mechanical engineers, civil engineers, automobile engineers, software developers, web developers, and so on. Okay, and what used to happen is that whether it's building a product or whether it's taking your decisions, whether it's lawyer, whether you're a lawyer, a finance analyst, or whether you're a mobile developer or a mechanical engineer and so on, you used to go by your own analysis of a particular problem, okay, without validating with the data, because data wasn't available so easily once upon a time. Okay, but that has now changed. Data has now been playing a greater role in both these areas. You cannot build a web product or mobile app without understanding how your customers are going to use them, or will they like it or not. Okay, so you need a bunch of historical data to validate that before investing time, money on developing products. If you are a mechanical engineer, you'll have to analyze a vast amount of data before going ahead with building a bridge and somewhere. You need to understand what is the reliability aspect of the construction that you are going to do, and that will be supported with the vast amount of data historically that's available with and the failure rate, and whether, I mean, I'm not an engineer so I can't explain, but those who are engineers, they will be able to relate to the fact that previously data analysis wasn't that important in engineering, where you would simply apply what you have learned, but now you will see the previous construction and whether they had failed or not, and what were the reasons why some particular engineering projects did fail. You'll analyze that before going ahead with any mechanical or civil engineering projects. Okay, so in general, any software development project is now has to be somewhat backward approach, right? You simply don't start software development right away with some idea. You first analyze the historical data available in that particular area and analyze how you should develop products. It's not just you who will take the decision how to develop, rather it will your audience reactions or your audience data that will give you the insight to ensure that you develop something that will be liked by your target audience. Okay, so that has been the change, and I'll talk more about it in the next slide. Okay, now going to we talk about this professions A group. Okay, whether it's you are a finance analyst. Okay, now there were analysts who would we were value analysts who would believe their gut. They would rather believe the intuition over any data when it comes to investment. Okay, but you cannot explain um, intuition to your customers directly, right? So people who have invested money in your fund, they will ask questions and need to give a valid reason to do that, and that's where data analysis is so important. If I validated your things historical with the historical data, then you can explain things to your investors, customers, and so on. Okay, similar with lawyers, right? You have massive amount of data from past litigation processes in different countries. If you can analyze that and get better insight, you will be a better lawyer. Similar journalist, right? If you're a journalist who can simply write good stories without being able to analyze data or historical data in particular, you wouldn't be able to communicate your story properly, right? You will be able to communicate it much better way if you're a data analyst at the same time. And if you're a marketing a sales analyst, you will be a much better marketing manager if you know how to analyze marketing data. Okay, so that uh, it may not be the guiding principle, but it will certainly help you validate your idea. Okay, so if you have some idea which is very risky, So you should be able to measure your risk factor, the risk involved in that idea. If you can just go back to historical data and see whether it's going to make profit or loss, and quantify that, and then take a risk. That's much better way of you know being a marketing or sales manager. Same thing with operations. Operations is now being highly automatized, right? You automate a lot of these operation tasks and so on. So there also you need a lot of data to ensure that where you can actually optimize things, okay, in a better way, so that you will have less time. You can do things faster, and you can do things much more efficient way. uh, if you're a management consultant, okay, and you are helping clients in terms of making profits and so on, it's not just your story that's going to matter anymore. You have to come up with you know validating your ideas, your stories with concrete data. That's what the demand is. So that's also important for them as well. In past, question is why in past, I mean, these professions were anyway there in past. They have been there decades ago, right? Over a century ago, we are having these professions. But why data is so important now? Because data collection was always difficult. Okay, you go to people, you ask for data. It costs a lot of money and effort to go to people and get data, right? So data collection was always very, very difficult. uh, and computing was also very less accessible. It was accessible to only a select few organizations, the top large organizations, government, research firms, military, and so on, because it was very expensive. Okay, remember in the Second World War, during that time, the scientists in the Los Alamos laboratory, they had access to computing. Okay, but many organizations, the mid-sized organization, didn't have access to any computing, so they had to do everything manually. So manual computation is horribly difficult task to do. So in past, these were very difficult to do and very expensive. But what's happening presently is that we have access to digital data. Data collection has become so cheap and so easy to do, and there's so much of data out there. Computing is also so cheap nowadays, right? The computing power of a mobile phone now is much more than what the computing power of many these large computers, IBM computers, in 50, 60 years ago. Now computing is so cheap. Even you can access to different cloud sources where you actually don't own these computers or servers or the infrastructure. You just pay some money and you can get the computation for few hours, for few days, or few months. Okay, so that's also possible in our time. That's why the use of data in whether it's building product or providing service has become so common nowadays. All right, so few difference, okay, the way things used to happen in past and now how it's changing with the introduction of data, how it has changed things completely. Okay, I'll talk about in brief, and those who are working in different fields, I'm sure they will be able to relate. So in past, what used to happen is that most because there was no data to even analyze to start with, people used to start with some hypothesis or some theory or some stories, and they, without even validating these theories or hypotheses, of course there were no data, there's no access to computation, so they would rather do very basic analysis to come up with business rules. Okay, um, and these business rules will then be implemented for building products or services. And what used to happen is that many times you will face a tough failure, because the product that you have built for so many years, or we have spent so much of money, is not going to be liked by the people because you didn't quite validate that beforehand. Okay, similarly, the services that you provided, whether in terms of investments, whether it's providing any kind of service, that's not being liked by the audience, and it fails many times. But those things can be reduced to a large extent with availability of data. Now, in the present scenario, what's happening is that you have massive amount of data. So you don't start with your theory or story or hypothesis, you rather start with the data. What data is available for a given problem? For a given problem, you don't have to start writing the problem statement and then start solving it with some some set of axioms and so on, pretty much the way we used to do school mathematics and so on, with theorems and axioms we used to solve problems, right? You don't have to do that first. Now you have enormous amount of data in whatever area you are working in. So make sure that you gather enough data about the problem that you're going to solve, and then try your best to get insight. Okay. So you can get insight through visualization, to through simply taking summary statistics, which could be very basics, or it could be building some more sophisticated models. Okay, mathematical model, statistical model, or ML models. Okay, so you will get a lot of insights, a lot of knowledge out of your data. Okay, so you then categorize that the understanding you had from your domain. Okay, and then the knowledge, so data gave you some knowledge, and your domain, your own theory about a particular problem gave you some knowledge, right? Then you point them out in different, you just tabulate them, see the difference, and then you take uh, see how the different. So this is more of a validation. Okay, this is more of a validation that you are doing before even putting your effort. Okay, and then you come up with your business rule, and this business rule will be very different from what you used to have the business rule previously. Okay, it will be much finer, right? It will be very target oriented and result oriented rather than what you used to have. And then you implement. The most important thing is that previously business rules used to be static. Okay, because your story is not going to change very soon, or rather it will take much longer time to change. But the human emotions, whether it's investing in stock market, or using social media, or preference towards a particular consumer product, um, will change very soon. It's not going to wait for decades time to change. It's going to change very soon. But then the theory hypotheses are not going to change soon, so you are not able to keep up with the change in the behavior of people or people emotions. But now with access to data, you can readily get the change in, you know instantly get everything. If people start hating a particular product and their preference is now something else, you'll get to know that. Okay, real time. Okay, so that real time analysis is there. So business rules are no more going to be static, they are going to be dynamic, and that's the main difference between what used to happen in past and now what's happening, because data is changing, right, every now and then. Okay, so data collected from Twitter, any social media, it will change over time, right? If data changes, so is going to the insights, and that will also impact the business rules. Okay, and so your products and services are going to change. Now you can see many businesses are pivoting, right? Pivot is a word that is now being so popular because businesses are changing their strategy to be more relevant to the time, and they're doing it at a very faster rate. In the history there weren't many companies were pivoting rather to different areas, because for them validation used to take a lot of time. So by the time they actually validate, they were either bankrupt, or maybe they, in some instances they succeed in doing so. But now it's much easier because you can do even validate on a real time basis, because you have access to data, so much of data. So where does data science, because we were talking about data science, and how does data science come into this picture about all these things? Well, data science is one interesting area. Well, even I used to not like this word called data science, because it looks very fancy, and it catchy and so on. And a lot of people in this area actually don't like this word, because people think that anyway we were using data analysis. But the fact that using research, so to say, in business wasn't that very popular even 10 years ago. You wouldn't hire a scientist, even 10 years ago. Only banks used to do that. Banks, hedge fund, these people used to do that, for data analysis, for business research, and so on. Other scientists, like the auto companies, the pharmaceutical company, used to hire scientists for their industrial laboratories for development of products, but they wouldn't hire someone, you know, for strategy making, or to help them fine tuning their products and so on. So that used to be, they wouldn't hire mathematicians, so to say. Okay, but now things have changed. Okay, so data science is one beautiful area which combines your maths, engineering, your creative aspect, whether you are interested in art or languages, your puzzle solving skills, your domain skills, and so on. So it combines your childhood, where you were interested in knowing things without looking at the commercial aspect of particular thing you are interested to. So pure creative interest, that's is part of data science. Then you started building products and services which have commercial importance. Okay, and the third one is that which is fundamental research, which is doing something that's not going to be useful now, but it's going to be useful in future. You are predicting future. Okay, what's going to happen 2 year, 3 year, 5 year down the line. Okay, previously we were not very worried about that, but now that's the most important thing for a company or for a business to survive, that you should know everything beforehand. And data science is one beautiful area that combines everything. And that's why no matter which profession you choose later on in life, in most profession you would be the numerical skills, computational skills are going to be very useful. And even if you're in creative side, you're an entertainer, you're an artist, and so on, these skills are going to be invaluable. And remember, mathematics wasn't even taught in schools a lot of long ago. Unless you are becoming a mathematician in future, mathematics wasn't taught in schools. If you're going to be a carpenter, or you're going to be some in some trade professions, you're not expected to learn mathematics. But later on people realize that maths is an integral part of your should be an integral part of your curriculum, and that's how you started learning a lot of maths, irrespective of whether you are interested in language, social science, or something that is completely unrelated to maths or science. Things changed. So maths has now become general area. My prediction is that computing, which is some form of data science, is going to be also more of a general skill in future. Okay, so we say that, right, you should have reading, writing, arithmetic, right? Reading, writing, and arithmetic are the basic skills taught in schools, right? Computing will be another basic skill to be added. In many countries, in fact, they have already started computing curriculum in schools, and each and every student is now being taught what computing is, or thinking computationally. But over time this is going to be part of the curriculum. So it's not just reading, writing, arithmetics. Computing is also going to be part of the basic curriculum in schools. Okay, so the few takeaway points before I end this particular session. Well, computational thinking is going to be very important in future. So in every professions, people who can think computationally, not just intuitionally. I mean, people who are very good at intuition, that no matter they are very good, but it's very difficult to understand who is good at intuition, right? So computational thinking will be very important in almost all professions in future. Uh, Second important thing is that validations, right? Validation of your work prior to you do anything, that used to be not that used to not happen long ago, because there were no computing power to analyze historical data. So classic example would be investment. Quants are now using you are being heavy in demand in investment firms, where they analyze previous data before they allow the actual investors to invest money in different areas. Software developers, another classic example. You used to write only a business rule directly, static code, but now coding is not static anymore. It is now changing with more dynamic features. The software if you're a developer in maybe 30-40 years ago, you will simply write the business rule with if and else statement, with looping and so on. But now things have changed. So people are now using a lot of um, insight and a lot of predictive behavior to write coding. And by the way, machine learning is something which is automating code writing. So it is making coding more dynamic, so to say. Education will get impacted. So the way we are being taught in schools is going to change heavily. We'll have more computational thinking courses in schools in future, and that's important. That if our kids are already familiar with computational thinking, they will be far ahead of their peers in professions later in life.